Hello, welcome everyone to the ultimate recap session of the most important chapter in the history of class 11th and 12th, which is trigonometric function. Yes, you heard me right. It is the most important chapter. Welcome all to PW Gulf, the one and only channel which is there for all the students out there who is willing to prepare for class 11th and 12th. Alright guys, this is Varsha and I welcome you all once again. Why am I welcoming so much? Because next 1 hour is going to be super amazing, super intense for all those who know trigonometry as well as those who don't know trigonometry. Nothing to worry guys. All the formulas and how to remember those formulas will be discussed in today's class. You heard me right. Okay, before I begin today's class, there's a very powerful quote you must have heard. Future belongs to those who have the power to dream about it. Yes, for those who can dream and believe in it, you will have a future. For those who don't think about your future, do not have the vision to think about the future, will never achieve it. They will get whatever comes on their way. They may like it, may not like it, but yes, if you think about it, you can definitely have a path, a plan to reach that goal. And this reminds me of a very funny incident. It so happened that after few years, my 11th-12th standard best friend, yes, when I was your age, my best friend, and we happened to be losing contact after the 11th-12th standard, and we met lately just few years back. And when I told her that I am a mathematics teacher and I teach chapters like derivative, limits, trigonometry, she said, she just reminded me one thing. Do you remember the very first test in mathematics which we both appeared together and we both got 3 marks out of 20, and that was the day we thought we are going to leave mathematics forever and will shift to biology because we could ratify easily. That was the first thing she reminded me when I told I am a mathematics teacher now. We were not in contact for many years, but yes, life, journey, destiny, when we meet, nothing like it. So that was a time when I scored only 3 marks and thought of leaving mathematics, and today I am teaching mathematics from many years passionately to all my students. You never know where life takes you, but do not stop dreaming. Believe in yourself and something good will definitely happen to you. What all things are going to be covered in this chapter? Measurement of angles, the very first topic, then trigonometric functions, the 6 trigonometric functions, sum and difference, multiple, submultiple angle and transformation formula, which is product to sum and sum to product. For trigonometric equations, I'll bring another session. I am not combining it in the same chapter. In the next summary session, you will get trigonometric equations in detail. So, introduction to trigonometry. What is trigonometry? So, in ancient times, people used to use trigonometry in sound navigation system a lot to detect if there is something inside the water, pirates, etc. Also, it was used a lot in designing, construction, yes, designing of rooms. At what angle should be the ceiling, at what angle should be the different things inside a room. You know, ancient monuments, those are unbeatable, and yes, all those required a lot of trigonometry. So trigonometry has a vast advantage. The word trigonometry, you all know, is made up of 2 words, trigon, which means triangle, and metry, which means measurement. So everything related to triangle, its sides, its angle. When you measure angle, sides of a triangle, it's a part of trigonometry. Alright, that's a basic introduction. Now, in trigonometry, the first thing that we will study is measurement of angles. How to measure different angles. how to measure different angles. So let's consider an initial ray OA. O is the vertex, OA is your initial arm, and now if you're rotating this OA, it will reach to another position, let's say OA dash. This angle is theta. OA is called as the initial arm. Let's say this is your initial arm, vertex, initial arm. Rotated, it reaches to a final position called as terminal arm. The angle between initial arm and terminal arm is called as theta. We are interested in measuring this theta. Now, well, you must have seen I rotated it anti-clockwise. So anti-clockwise rotation will be counted as positive. It is just a convention, like in physics, current, electricity, you have conventional direction of current. Similarly, so anti-clockwise, if your angle is moving, it's taken as positive, and if this initial arm OA is moving clockwise like this, then that angle will be taken as negative. Clockwise angle we take negative. Let me write minus. Simple thing to remember. Anti-clockwise positive, clockwise negative. So sign of angle, if I take different angles, let's say this is your x and y axis. Okay, I am taking some angle 30 degree. Looking at the arrow, this theta is plus 30 degree. Fine. Another. Okay, sorry. Yes, another angle. Now look carefully, very carefully, x and y axis I have drawn. The angle is rotated like this. Can you tell me what is theta in this case? Everyone, what is theta in this case? Firstly, I am moving anti-clockwise, so angle is going to be positive. And how much I am rotating? So 90, 180, 270, 360, and 360 plus 90 is 450 degrees. So this is anti-clockwise 450 degree. Okay, let me take another color, red color, and tell me what is this angle. How much will this angle be? This red color. What will that be? How much is that? Suppose this is theta 1. Let red one be theta 2, and theta 2 will be equal to, because it's clockwise, negative. And how much has it moved clockwise? It started from here, ended here. So it has moved 180 degree, right? We generally start at guys, origin. So let me start this at origin. Okay, this is theta 2, 90 degree, but in the clockwise direction. Similarly, taking it further, how much is this? Minus 180 degree, and so on and so forth. So you can keep on playing with these angles. You do not restrict yourself at 360, 456, 450, 540, 630, 720, 810, 900. It keeps on adding 90, 90, 90 will give you multiple angles. And in class 11th, we are not dealing with smaller angles but very large angles also. How do we measure all these angles? How do we measure? So we are going to use 3 systems to measure. We are going to use 3 systems to measure this angle. What are the 3 systems? Centesimal system, sexagesimal system, and circular system. These 3 systems of measurement we are going to use for measuring angles. Most of you would have heard about sexagesimal and circular, but not centesimal. Nothing to worry. The unit of measurement in centesimal is grad. Written like this, x in the power we write small g, x grad. In sexagesimal, the unit of measurement you know very well is degree. How it's written? In the power you write 0, x degree. Circular system of measurement is nothing but your radian system of measurement. Grad rad, radian, written as x in the power, not r, in the power it's c, or simply x if you write, that also means radian. If nothing is mentioned, by default it's radian. So radian is also the default unit of measurement. It is the SI unit of angle measurement. It is the default unit of angle measurement. Okay, we understood what is this 3 system. Let's understand further about their conversions also. So in centesimal system, one right angle is considered as 100 grad. This was mainly again used by naval people. They need a lot of right angles, and for simpler calculation, instead of taking right angle as 90 degree, they considered right angle as 100 grads. 1 grad was equal to 100 minutes and 1 minute was equal to 100 seconds. Single line minutes, double line seconds. When it came to sexagesimal system, they started taking one right angle to be equal to 90 degrees. Alright, one right angle 90 degree. 1 degree was equal to 60 seconds and 1 second was equal to 1 degree was equal to 60 minutes and 1 minute was equal to 60 seconds. Are you able to understand? Then comes your circular system. For mathematics, for calculus, for astronomical purposes, this centesimal and degrees didn't prove very useful. So for astronomical purposes, radian measurement was very convenient, and hence we shifted altogether to radian measurement. What is this? Circular system. So in circular system, by definition, they say inside a circle, if this is your radius and the angle made at the center is theta by length of arc AA dash. This AA dash is nothing but length of arc. If radius is r, length of arc is L, then the angle made at center is called as theta radians. The angle made at center is theta radians. Let's assume your radius and L is 1. So theta will also be 1. Length of arc is 1, radius is 1. How many radians? 1 radian is made at the center. So this was your circular system of measurement inside a circle. Can you all understand this simple funda? Let me draw a circle. This is your center of circle. This is theta in radians. Length of arc A, this is A dash. Just now I told you a formula. Theta is equal to L by R. Theta in radians is nothing but length of arc divided by radius. How much is the length of arc in this particular circle from A to A dash? How much is that distance? It's a semicircle. Total circumference is 2 pi r. So A dash, that's your length of arc, is pi r, half of 2 pi r. Pi r, correct? Theta in radians, pi r, divided by what's the radius? Radius is r. Radius of this circle is r. Length of arc is pi r. Theta is L by r. Can you see? You get pi radians. So this angle is pi radians. But in degrees system, it is called as 180 degree. And there we get one relation between radians and degrees. pi radian is equal to 180 degree. Pi radian is equal to 180 degree. You all remember pi is 3.14 or 22/7 pi log. I just spoke about some relation between degree and circular. Yes, I am going to talk about some relation between centesimal and sexagesimal, that's grad and degree also. Is there any conversion between grad and radian? It is there, but not in our syllabus. We will not deal with these two conversions. We will deal with first, second, second, third. How to convert between first, second and third. So here comes the conversion between degree and gradients. Simple conversion, degree is nothing but 90, one right angle is 90, and in grad one right angle is 100. Using this you can solve any question between degree and grad. Let's say the question is convert 10 degrees to gradients, 10 degrees to grads. Okay, now this is D. Capital D is given to us, 10. Substitute here and you will get G. Therefore 10 upon 90 is equal to G upon 100. This cancels up. G is equal to 100 upon 9. So 10 degrees equal to how many gradients? How many grads? 100 upon 9 grads. Easy to remember this conversion. In degrees 90, in grads 100. One right angle is 90, one right angle is 100. So that's how you convert between degree and gradients. How to convert between degree and radians now? Let's understand the conversion between degree and radians. As we all just said, pi radian is 180 degree. So 1 radian is equal to 180 upon pi degree, or in general x radian is equal to 180 upon pi into x degree. So whenever you have to convert from degrees to radians, what we will do, and whenever the question is converting from radians to degrees, whenever you will be wanting to convert from degree to radian, simply multiply it with pi by 180. Multiply your number with pi by 180. You will get the final answer in radians. Nothing written means radian. And whenever the question is to convert from radians to degrees, multiply that particular number with 180 by pi. The answer will be in degrees. Please write this formula. The two boxes important for conversion between degree and grad, between degree and radians. Are you able to understand? Very simple logic. Can you see radian to degree? 180 by pi. Similarly, this same equation I can write, since pi radian is 180 degree or 180 degree is pi radian, 1 degree is equal to pi by 180 radian. In other words, x degree is equal to pi by 180 into x radian. So degree to radian conversion into pi by 180. Forget about how it comes for now. Our main focus in summary session is to know the formulas very well, although I am telling you from where it's appearing. Alright. Okay. Dealing further, guys. Now once you understand radians, your main focus should be on radians. Grads, alright, not there very much in the syllabus. Degrees, you've been dealing with it since ages now. Radians, something new. So very well you must all understand and by heart the standard values. As I said, pi radians is equal to 180 degree. Some standard, pi by 2 radians is 90 degree. Pi by 6 pi by 3 radians is equal to 60 degree. Pi by 4 radians is equal to 45 degree. Pi by 6 radians is equal to 30 degree. And what else? 0 radians is equal to 0 degree. If pi is 180, 2 pi radian is 360 degree, and so on and so forth. You know why I am writing all these values? Because any multiple of 90, pi by 2 is called as quadrantal angle. It is called as quadrantal angle, standard angles. When we by-hearted the table of sine, cos, tan, sec, cosec, cot, we by-hearted it for 90, 60, 45, 30 and 0. Only this much, 0 to 90. In class 11th, it is not going to be restricted from 0 to 90. It will go further to 180, 360, 450, 540, 630 and many other values in between. So yes, it's going to cross 90 and you will all know how to find those values by the end of today's class. So stay tuned very well. Have some water, freshen up and then sit. With this, let's solve couple of questions in conversion from degree radian, radian degree. The very first question, I think I have it written. The question is written. Convert 10 degree 30 minutes into radians. Now when I have to convert it into radians, one thing that is going to help you a lot while you're converting from degrees to minutes in physics, bring your physics place. Degrees to minutes, it's like meter to centimeter. You multiply or divide. When you're going from meter to centimeter, you multiply. Higher to lower, you always multiply. From minutes to seconds, if you want to convert, again you will multiply by 60. But let's say you want to convert from seconds to minutes, divide by 60. And you want to convert from minutes to degrees, lower quantity to higher quantity, again divide by 60. So remember this flow chart. It will help you in solving questions. Alright, so here is a question. 10 degree 30 minutes into radians. Firstly, it's minutes. 10 degree 30 minutes. That's equal to 10 degree plus 30 minutes, which is equal to 10 degree. Let's convert this 30 minutes into degrees first and then we'll use the conversion formula. 30 minutes to degrees, all we do is minutes to degrees, lower to higher, divide by 60. This is equal to 10 degree plus 30 by 60, 1 by 2 degree. 10.5 degree, you can either write it as 10.5 degree or cross multiplication 21 by 5 degree. Let's write it 21 by 5. That will 21 by 2. Okay. So I have just written down the degree format. Question is to convert it into radians. Now we can proceed very nicely. 21 by 2 degree according to the formula is 21 by 2 into degree to radian, multiply it with pi by 180. 3 7s are, 3 60s are, 7 pi by 120. How much is 10 degree 30 minutes? It is 7 pi by 120 radians. How much is 10 degree 30 minutes? It is 7 pi by 120 radians. First converting minutes, seconds, everything should be formulated in degrees and then apply the conversion formula. Alright, one more question. I'm not giving some simple questions, right? You have it in your textbook questions like this. Convert 3 pi by 4 into degrees or convert 315 degree into radians. So how do you do? Multiply or divide by pi by 180. And then, okay, how will we divide this? 5 ka table, 25 ka table, 5, 5, 5. 90 का टेबल, 90 का टेबल, या 9 2s are 18, 9 3s are 27, 4 9 5s are 45, 35 pi by, no, it can go further in 18 table also, I guess. 35 pi by 20, which can be further broken down as 7 pi by 4. 7 pi by 4. 5 further broken down by dividing with 5. So these are simple questions you can do. I deliberately took a question on minutes and seconds. Again, convert 1 radians to degrees. Simple questions can be asked. For example, how much is 3 pi by or 7 pi by 6 radians? Convert it into degrees. 7 pi by 6. If you want to convert it into degrees, 180 by pi you will multiply. That shall give you the answer in degrees. Pi cancel. 6 1s are 6 3s are 30. 7 3s are 210 degrees the answer. Simple question. Let's come here. 1 radian we have to convert. Important. Now, according to the conversion formula, radians to degrees means multiplying it with 180 by pi. Now this is all in degree. Multiplying it with 180 by pi. Pi doesn't remain pi. Pi is 22 by 7. That 7 will go up. Okay, can we simplify? 2 9s are 90, 2 11s are 7 9s are 630 by 11 degree. Are we going to leave the answer at this 630 by 11 degree? No. It's exactly reverse process of what you did. From 7 pi by 20 you come to a fraction. From fraction you will come to minutes and seconds and degrees. From fraction you have to convert it back to degrees, minutes, seconds. Reverse process. From radians to fraction. Now fraction will further get converted into degrees, minutes and seconds. And how? Please notice carefully. Try this in many questions. This will simplify all the questions. It's not difficult. Just follow the process. Whenever you get a fraction, divide it and try to write it in mixed fraction. I hope you all remember what is mixed fraction. You divide and just write the denominator. So 11 5s are 55. 11 5s are 55. How much will be carried? 8. 11 7s are 77. 3 out of 80, 3 left. So 57 3 by 11 degree, which can be separated and written as 57 degree plus 3 by 11 degree. This is still not the required answer. I want degrees, minutes and seconds. So 57 degree as it is, 3 by 11. Whenever we convert degrees to minutes, higher to lower, the conversion flow chart, degrees to minutes multiply by 60. This makes it minutes. 57 degree, 3 6 180 by 11 minutes. Is this the required answer? No. Further, mixed fraction again. Whenever you have a ratio, converted in mixed fraction. Correct? So 180 by 11. 11 1s are 11. 11 1s are 11. Yeah. I'll carry over 7. 11 6s are 66. 4 will be left. So 16 4 by 11 minutes is what I get from ratio to mixed fraction. You can check for yourself, everyone. Separate it. Once you get a mixed fraction, separate. This is 57 degree plus 16 minutes plus 4 by 11 minutes. 4 by 11, we don't need ratio. We need seconds now. This is equal to 57 degree plus 16 minutes plus 4 by 11 minutes to seconds. From the flow chart, higher to lower, multiply. This is 57 degrees, 16 minutes, 4 6 are 24, 240 by 11 seconds. Further, we will write it in mixed fraction, and rather we are going to just sum it up now, because 240 by 11, 11 2s are 22, 2 carry, 11 2s are 22 to carry, 11 1s are 11, and what will be left? 9 by 0.9, 21.9 seconds something, which I can approximate to 57 degrees 16 minutes 22 seconds. That's your final answer on solving. And I want you all to remember directly 1 radian is equal to 57 degrees 16 minutes 22 seconds. Everyone will remember this value from now onwards. If the question is 4 radians, nothing changes. Convert 4 radians into degrees, just 4 will be multiplied everywhere. The final answer will be multiplied by 4. So you can guess roughly 57 into 4, roughly 200, 220, something in between that, 221. Okay. So check out very well. Firstly, 1 radian was converted to degrees. Radian to degree multiply with 180 by pi. Pi value is 22 by 7. Always don't put 3.14 because it will unnecessarily make the calculation difficult. We don't like points, we like fractions. Fraction, mixed fraction. Mixed fraction, degree, degree separated. The rational part, the fractional part converted into minutes, degrees converted to minutes, multiply by 60. Again we get a fraction, mixed fraction, again separate, 16 minutes, 4 by 11 minutes separated, 4 by 11, multiply it with 60 to get seconds, again a mixed fraction, divide roughly 21.9, because it's second, the end part, we are just rounding off it to 22, that's the approximate value. Alright, so relation between arc, radius and angle, we studied theta in radians is equal to L by R. Remember this relation? Lot of questions is solved. I purposely write C here so you don't forget theta will be in radians. If the question has theta in degrees, do not blindly use 20 degrees equal to L by 30. Convert it to radians always. That was about measurement of angle. Radian to degree, degree to radian, and all those things. The important aspects have been covered. Now I am moving to next part, which is trigonometric functions. Another important journey is beginning. Trigonometric function. So some simple trigonometric functions which you have studied in class 11th. 3 identities all of you must be remembering. Sin square theta plus cos square theta equal to 1. 1 plus tan square theta is equal to sec square theta, and 1 plus cot square theta is equal to cosec square theta. So using these 3 identities you can solve all the questions very easily, or there is also a typical triangle method called as Pythagoras theorem. You all know Pythagoras theorem, right? And some standard triplets like 3, 4, 5 is your standard triplet. 2 sides 3 and 4, the hypotenuse will be 5. Similarly, or if one side is 5, other is 12. 5, 12 and 13. 5, 12, 13 is another. 3, 4, 5 is one triplet. 5, 12, 13 is another standard triplet. One side 5, other side 12. Hypotenuse will be 13. One side square plus other side square is hypotenuse square. Okay, tan theta is given. What will be sin theta equal to? All of you, sin theta we need. Draw a triangle for this. Why don't you draw a triangle? A triangle, one angle is 30, one angle is theta. In this triangle, tan theta is minus 4 by 3. Tan theta is what? By the formula, it is opposite upon adjacent, correct? Opposite is 4, opposite of theta, adjacent is 3. Opposite is 4, adjacent is 3. What will be hypotenuse? 5. Now in this triangle, if they ask you sin theta, you can easily find. If they ask you cos theta, sec theta, cosec theta, you can find all the values in fact, isn't it? Let's write down all the values. Sin theta will be opposite upon hypotenuse. Cos theta will be adjacent upon hypotenuse. What about the sine now? I'll come to it. Tan theta is already given. If sine is known, cosec can be easily found. 5 by 4. Sec 5 by 3. Tan is known, cot can be written as 3 by 4 minus sec. Now tan is negative. We also know all silver teacups add sugar to coffee, isn't it? First quadrant, everything is positive. Second quadrant, sine and cosec is positive. Third quadrant, tan and cot is positive, and fourth quadrant, cos and sec is positive. Add sugar to coffee. After school to college. All silver teacups. According to this funda, if tan is negative, where is tan negative? Either in second or in fourth quadrant, isn't it? Tan is negative either in second or fourth quadrant. And in second quadrant, sine is positive. In fourth quadrant, sine is negative. So what do I do? What will be sine theta? Will it be plus 4 by 5 or minus 4 by 5? It can be both. In second positive, in fourth negative. So the answer to this question is minus 4 by 5 or plus 4 by 5. In second quadrant, sine theta will be plus 4 by 5. In second quadrant, in fourth quadrant, sine theta will be minus 4 by 5. And why are we taking second and fourth quadrant? Because tan theta is negative in second and fourth. It is negative in second and fourth. That's why the answer is B. What about cos, cot? So if they have mentioned the quadrant, most of the easy questions you know in the textbook, all the easy questions they say theta is in third quadrant. So if it's third quadrant, you will just take tan and cot positive, rest everything negative. If they say theta is in second quadrant, you will put sine and cosec positive, rest everything negative. Fourth quadrant, you will take cos and sec positive, rest everything negative. So you know those simple variations. Let's move to the next question. If sine theta and cos theta are roots of this equation, ax square minus bx plus c equal to 0, then a, b, c, what is the relation between them? Which option? Roots of the equation, it is something related to your class 10th quadratic equations. So roots, alpha and beta. So let's say this is alpha and cos theta is beta. What do we know about these two roots? Do we know some relation between alpha and beta? Yes. Alpha plus beta is always minus of b by a. Here it's already minus b upon a. Sum of roots is negative coefficient of x upon coefficient of x square, and product of roots is constant upon coefficient of x. Alright, alpha plus beta, that's sine theta plus cos theta is equal to b by a, and alpha into beta, that is sine theta into cos theta, will be equal to c by a. Do we know some relation between sine theta plus cos theta, sine theta into cos theta? Yes, a very beautiful relation. Sine theta plus cos theta, the whole square is equal to sine square theta plus cos square theta plus 2 times sine theta into cos theta. What is sine theta plus cos theta? It is b by a. What is sine square plus cos square? 1 plus 2 times sine into cos, c by a. Simplify, you will get the answer. It's done, done, done. B square is equal to taking a square on the other side. A square plus 2ac. A square minus b square plus 2ac is equal to 0. Option once again, B is the answer. Can you understand? The question can be from anywhere, everywhere. Just try to go with the flow. Whatever you have. Now this was from quadratic equations. Suddenly came here. Similarly, you will find in class 12 that trigonometry is poking its nose in absolutely every chapter. Anywhere and everywhere you will find sine, cos emerging out of nowhere. And that is the reason all the formulas that I'll be introducing now, you have to make sure to do all those formulas thoroughly by hearted. One pro tip, if all of you really want to be a champion in trigonometric function, make a formula book, and go through that formula book every day the way people in India go through Hanuman Chalisa. Yes, that's the only way, because you have to remember all the formulas of this chapter till the end of class 12th. That means almost for 2 years. From now, if I count till your JEE exam and all, for 2 years you have to remember all these formulas, and it will come out, pop out anywhere. Make a separate formula book, write down each and every formula that we are going to study today. Okay, so let's start with introduction to trigonometric functions. 6 trigonometric functions we already know. We saw some basic questions, so things are revised. Okay, for people, yeah, I hope you all are very well aware of this: sine theta, cos theta, tan theta, cosec theta, sec theta, cot theta, 0, 30 degree. Now 30 degree is your pi by 6. Now your world has changed. Now you have grown up. Now the app is updated. You should be updated. Now you will not say sine 0. Okay, you will say sine 0, 0, but you will not say sine 30 half. You will say sine pi by 6 is half. Now you will say sine 45. No. Sine pi by 4. Sine 60. No. Sine pi by 3. And sine 90 is pi by 2. Okay. Now you will remember all these 6 values in terms of radians. My dear students, you have to remember it in, oh my god, you have to remember it in radians now. Rest all you know how to fill. Yeah, cos 0, 1, cos root 3 by 2, 1 by root 2, 1 by 2, 0, and then tan is it very well by uttered in class 10. But only the updated version now. If suddenly in a question comes, what is tan of pi by 3? Don't keep on converting pi by 3 to degrees and then tell the answer. Immediately, pi by 3, 60 degree, tan 60, root 3. Also there is a way, I mean, it's reverse. It's reverse. For 30, it's 6 here in the denominator. For 60, it's 3 in the denominator. I mean, it's opposite. For if 30, 6 will come. If 60, 3 will come. And for 45, it's same. 45 degree, it's 4. So 45, no change. But for 30 and 60, opposite you have to write. That's how you can remember for quickly solving such questions. Okay. Now, how about values of trigonometric functions greater than 2 pi, or in general, let's say allied angles? Instead of going to 2 pi, I'll simply go to allied angles. Next topic, and a very, very important topic, everyone. So, okay, there are few things in your textbook, like how the definition of sine theta and cos theta appears. Will refrain from going there. All the important things will be encountered as I promised. Otherwise, I'll have to take a session of at least 10 hours. And yes, in the regular classes, I have taught this chapter trigonometry for around 10 sessions, and each session is 1.5 hours. So 15 hours you can see. Allied angles, allied angles. Remember the thing that I'm going to tell now. Write it down. if A is an odd multiple of 90. Now what is this even multiple and odd multiple? Please understand this very nicely. We will come back to this once again. Sorry. Yeah. What is even multiple and odd multiple? You all know pi by 2. Even multiple of pi by 2. Multiply this pi by 2 with even numbers like 2, 4, 0, 2, 4, 6, 8. You will get numbers like this: 0 pi, 2 pi, 3 pi. Just multiply all of them, all the pi by 2 with all the even numbers. Of course, negative numbers also you will get. For now, I am writing positive. Is this what you will get? So remember, even multiples of pi by 2 is 0 pi, 2 pi, 3 pi, 4 pi, and so on. What do you mean by odd multiples? Remember, multiply pi by 2 with odd numbers like 1, 3, 5, 7, etc. You will get pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2, and so on. Okay, let's see where this even multiples and odd multiples lie on a graph. X and Y axis. Okay, on this X and Y axis, this is 0, 90 pi by 2, 180 is pi, 270 is 3 pi by 2, 360 is 2 pi. Again, if you continue this channel, you will see this is 450, 630, not 630, 540, 7 pi by 2, 4 pi, 9 pi by 2, 5 pi, 11 pi by 2, 6 pi, and so on, guys. It will keep on continuing like 0, 90, the angles. Can you see the even multiples lie on the x-axis and the odd multiples lie on the y-axis? Yes. Remember, even multiples x-axis 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, 10 pi, 11. Remember, even multiples on x-axis. So on x-axis you will see all the multiples of pi. You will see all the even multiples of pi by 2, which is also same as multiples of pi. Even multiples of pi by 2 is same as multiples of pi. Any multiple of pi, even odd both. On y-axis, you will see all the odd multiples of pi by 2. We all know sine 0 is 0, sine pi is also 0. So on x-axis, sine is also always 0. On x-axis, sine of n pi is always 0. All the multiples of pi, sine will be 0. First, second, third, fourth quadrant, you all know. First quadrant, second quadrant, third quadrant, fourth quadrant. Correct, guys? 0, pi by 2, pi, 3 pi by 2. And 0 is, if I keep on continuing the circle, 2 pi, and so on. For first quadrant, let's say if any angle in first quadrant is theta. If any angle in first quadrant is theta. In second quadrant, I can write it as pi by 2 plus theta. 90 plus theta means second quadrant, or pi minus theta, 180 minus theta will also be in second quadrant. Second quadrant, two ways, 90 plus theta or 180 minus. Similarly, if you want to go in third quadrant can be written in two ways, pi plus theta or 3 pi by 2 minus theta. Do you agree? Pi plus theta or 3 pi by 2 minus theta. If you add theta to pi, you will get third quadrant, or if you subtract theta from 3 pi by 2, you will get third quadrant. This is clockwise, 3 pi by 2 to this. Subtraction means clockwise. Addition means anti-clockwise. So pi plus theta clockwise will third quadrant. For fourth quadrant also there are two ways. One is 3 pi by 2. I am going clockwise. 3 pi by 2 plus theta, or 0 minus theta. I can write it as minus theta. 3 pi by 2 plus theta, or 2 pi minus theta. Do you agree? This is 2 pi. So 2 pi minus theta. These are the different quadrants of thetas. Okay. Now I wrote something here, very important for allied angles. Coming back to this, I'll explain this. T of A plus minus theta is plus or minus T theta if this angle A is an even multiple of 90. And T of A plus minus theta is plus minus T complement theta if this A is odd multiple of 90. You now know even and odd multiple, but what is this T? And T complement. T is trigonometric function, T complement is its complementary angle. The 6 trigonometric functions and its complementary angles are: sin theta is a trigonometric function. What is its complementary angle? Cos theta. Tan theta is a trigonometric function. Its complementary angle is cot theta. Sec theta is a trigonometric function. Its complementary angle is cosec theta. So whenever you have sin theta, suppose here there is sin theta and there is an even multiple, sin will remain sin. But if you have sin theta and an odd multiple of 90, sin will change to cos. Nahi samjha. I know. Let me take examples to explain you this thing. Suppose you have sine of pi by 2 plus theta. Can you tell me this pi by 2 is even multiple or odd multiple? It's an odd multiple. Everyone knows odd multiple. T will become T complement, sine will become its complement, which is cos theta. Okay, ma'am, you also wrote here plus minus. How to decide that plus minus? Now, how to decide that plus minus? Plus or minus decides on the basis of quadrant. On the basis of quadrant. That's why I taught you this quadrant funda. Pi by 2 plus theta is in which quadrant? Everybody will ask. Pi by 2 plus theta is in which quadrant? Everybody will ask themselves. Pi by 2 plus theta. Second quadrant. In second quadrant, sign is positive, negative. Sign is positive. So I'll take positive. Are you able to understand? Once again, nahi samjha. I know, don't worry. Every time in all the questions of allied angles, you will ask yourself two questions. The question number one will be odd or even, odd multiple or even multiple, and question number 2 will be which quadrant it is. All the questions you will ask two questions. All the questions you will ask two questions, odd or even, and which quadrant. For example, next one, cos of pi plus theta. First question, is it odd multiple or even multiple? Pi is odd multiple or even multiple? Pi is even multiple. So cos will remain cos. Guys, my dear boys and girls, if it's an even multiple, T will remain T, no change. Even multiple, no change. For even multiple, there is no change. No change. And if it's an odd multiple, you take its complement, correct? Even multiple, no change. Odd multiple, complement. So even multiple, no change. Second question, which quadrant? Pi plus theta. Pi plus theta, third quadrant. Third quadrant, cos is negative. Minus. In third quadrant, cos is negative. That's why minus. Next question. Everyone. Tan of 3 pi by 2 plus theta. 3 pi by 2 is even multiple or odd multiple? Odd multiple. So tan will change to its complementary cot. Second question, which quadrant? 3 pi by 2 plus theta is which quadrant? 3 pi by 2 plus theta. Fourth quadrant tan is positive or negative? Fourth quadrant tan is negative. Minus is the answer. Simple. Are you able to understand the logics? That way so many questions can be formed. Alright, I am moving further, making it little complex. 3 pi plus theta. Everybody, 3 pi, 0 pi, 2 pi, 3 pi, 4 pi, 5 pi, it's all even multiple. So even multiple sec will remain sec. Even multiple same, odd multiple complement. Same. 3 pi plus theta, which quadrant is it? So now you will know 0 pi, 2 pi, 3 pi. 3 pi is here. 3 pi plus theta will be in third quadrant. Third quadrant, sec is negative. Only tan and cot is positive, sec is negative, minus sec theta. Are you able to understand? These two questions will give you the answer. Always for all allied angles, and remember this very well for all your questions, guys. 3 pi, how to remember 3 pi? That's the reason we learned here. Even multiple 0, 2 pi, 4 pi, 6 pi here, pi, 3 pi, 5 pi here. Are you able to understand? So 3 pi, when they say 3 pi, you should be able to realize quickly. 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. If it's pi by 2, then pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2, 11 pi by 2, and so on. Next, last question I am taking on this. What will be cosec 11 pi by 2 minus theta? Now, where is this 11 pi by 2? Firstly, it's odd or even? Odd multiple. So, cosec will change to its complementary, which is sec. Cosec will change to sec. Odd multiple, boss. Take the complement. Which quadrant is 11 pi by 2 minus theta? Now, where is 11 pi by 2 minus theta? 11 pi by 2. 1 pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, 9, 11. Here is 11 pi by 2. We want 11 pi by 2 minus theta. Minus theta means clockwise. In third quadrant. It is in third quadrant. And in third quadrant, cosec is negative. So, answer is minus. Negative. Awesome blossom. Able to understand very nicely. This is what the table is. This is nothing new. All you need to check. Take any value randomly. Tan of pi minus x. Can you see tan of pi minus x is minus tan x? Why? You all know now. Pi is an even multiple, tan remains tan. Pi minus x is which quadrant? Second quadrant. So in second quadrant, tan is negative. Second quadrant, tan is negative. Pi by 2 plus x is also second quadrant. Pi plus x is third quadrant. Pi by 2 minus x is first quadrant. Take randomly any other value. Cos. Cos of pi by 2 plus x is minus sin x. Why? Pi by 2 means cos will change to sin. Complement. Pi by 2 plus x, second quadrant, cos is negative. That's why minus sin. In second quadrant, cos is negative. That's why a minus. This whole table should be made by you. It's a homework, and not just this table, but next one also. 3 pi by 2 minus x, 3 pi by 2 plus x, 2 pi minus x, 2 pi plus x. This is your third quadrant, fourth quadrant, first quadrant. So all 6 trigonometric functions in different quadrants, what will be the value? You have to fill this table yourself. Just write down the headings and fill this table yourself. Once you practice it thoroughly, your allied angle is done, and it is the most important segment of this chapter. Okay, great. Moving on further now. Sign of trigonometric function. Sign of trigonometric function. Sin of minus x is minus sin x. Cos of minus x is plus cos x. Tan of minus x is minus tan x. Cosec of minus x is minus cosec x. Sec of minus x is sec x. And cot of minus x is minus cot x. Point to be noted, my lord. Point to be noted, cos and sec gulps the negative sign. They absorb the negativity. Cos and sec will always absorb the negativity. Rest everyone, they throw out the negativity. But these two guys, cos and sec, these two sisters, reciprocals of each other, they will always take the minus sign. For example, how much is cos of minus 30 degree? It is same as cos of 30 degree. And what is cos of 30 degree? Root 3 by 2. But what is sine of minus 30 degree? It will be minus into sine of 30 degree. Minus sine 30 is 1 by 2. Answer will be minus half. Are you able to understand the difference? Very good. Alright, based on that, a simple question. Let's say if you have to find the value of sine of 120 degree. Through the help of allied angles, we can easily find. Sine of 120, guys, can I write it as sine of 180 minus 60? Why 180 minus 60? Changu is saying, ma'am, I can write it as 150 minus 30. Yes, 150 minus 30 is also 120, but 150 is not a quadrantal angle. Okay. In the beginning, I said what is quadrantal angle? All the multiples of 90, the standard angles are quadrantal angles. So 180 is a quadrantal angle, 150 is not. Don't take it. Sine of 180 minus 60. Now remember, 180 is an even multiple or odd multiple? It's an even multiple, right? 0 pi, 2 pi, 3 pi. Pi is 180. It's an even multiple, so sine remains sine. 180 minus 60, which quadrant? Which quadrant? Two questions. It's even or odd? So right now it's even multiple. Second question, which quadrant? 180 minus theta is second quadrant in which sine is positive. So the answer is going to be root 3 by 2. Sine 120 is what? Root 3 by 2. But if the same question, cos 120, I can write it as, ma'am, can I write it as 90 plus 30? Okay, you can write it as 90 plus 30. No problem. Okay. 90 is an even multiple or odd multiple, boss? 90 is a even odd multiple of 90. Pi by 2, 3 pi by 2, 5 pi by 2, odd multiple. So cos will change to sine. I wrote sine 30. This is t of a plus theta equal to t complement theta. Again, quadrant 90 plus 30, first quadrant or second quadrant? Second quadrant. Second quadrant, cos is negative, minus. And the answer is minus 1 by 2. For this above question also, you can write it as 90 plus 30. This can be written as sine of 90 plus 30. Because it's 90, sine will change to cos. And the quadrant is second in which sine is positive, so plus sign. And cos 30 is root 3 by 2. Whether you do it by this method or this method, the answer will not change. Sine 120, whichever method you use, the answer will remain same. Similarly, cos 120 can be written as cos of 180 minus 60 also. Solve it, you will get the answer minus 1 by 2. And similarly, many other values can be found. If they ask you tan of 150, didn't I tell you, you have by hearted standard angle 0, 30, 60, 45, 90. But now you will be able to find all other values. Tan 150, my dear kiddo, can I write it as 180 minus 30? And 180 is an even multiple, tan remains tan. 180 minus 30, second quadrant in which tan is negative, so minus 1 by root. Value of tan 150 is minus 1 by root 3. Are you able to understand? Great, very good. So let's now raise the level. Here is a very simple question. What is the value of tan? 1 degree into tan, 2 degree into tan, 3 degree dot goes on till tan 89 degree. Total of 89 terms. Okay. Try solving it by pausing. Use all your approaches. I am not taking the straightforward questions in your exercise. I believe you have done it in the regular sessions. It's summary, so I want to take questions a step ahead, mostly from miscellaneous, RD Sharma and exemplar. That's what I aim at. So in order to solve this question, color, which color do you want? Do you want? I can write this as tan 1 degree. Everyone agrees tan 89 degree can be written as tan of 90 minus 1, tan of into tan of 2 degree. Now before 89 there will be 88, which can be written as tan of 90 minus 2. Again tan of 3 degree. And before 88 there will be 87, which can be written as 90 minus 3, and so on. The process will go on. What will be, where will it stop? We are taking first number, last number, first, second and second last, third and third last. Which will be the last one? 1, 2, 3, from behind 89, 88, 87. It will come and club at tan 45. Rest everything is making pairs. 1, 2, 3, 4, 5, 6, 44. It is making pairs still from the behind. The middle term is tan 45. Okay. Tan 1. Tan of 90 minus theta. Now we just studied how much is tan of 90 minus theta, my dear bachos. 90 is an odd multiple. Tan will change to what? 90 minus theta is first quadrant, positive. So this cot of tan of 90 minus 1 is cot 1. Similarly, tan 2 into cot 2, tan 3 into cot 3, tan 4 into cot 4, ऐसा करते करते tan 45. What is tan into cot? What is tan into cot? 1. Very good. So can you see the answer now? What is the answer, everyone in the chat? Tan into cot is 1. Tan cot 1. Tan cot 1. Tan cot 1. 1, 1, 1. 1 into 1 into 1 into 1 into 1. These dots are nothing but 1. The answer is 1, option B. So far all the options are B. Why? The answer is B. Are you getting it? Allied angle. These two formulas we use. Two questions, even or odd multiple, and which quadrant it is. Next one, graphs of trigonometric functions. Now get ready to dance. Dance karega mere saath. For graphs of trigonometric functions, the main aim is to understand the domain and range. The main aim is to understand domain and range of all the trigonometric functions. Sine, cos, tan, cot, sec and cosec. And you will be by hearting this. If you by heart this, your next year there is a chapter called as ITF, inverse trigonometric functions. Trigonometric functions, inverse trigonometric. If you understand inverse, if you understand trigonometric, you will understand inverse trigonometric. So remember this chart. Next year all you have to do is swap. You will be swapping the domain range next year and doing that chapter. But if you don't understand this year, next year you won't be able to. Again, you have to anyways by heart next year, so why not do it this year itself? Okay. Alright. Now, I can directly write the values and ask you to by heart. But this is Varsha, right? I am not going to do that. We will understand it through graphs. So this sine function, domain is your input, range is an output. You all know that very, very well. Anything new? No, ma'am. Domain is x-axis, range is y-axis. Do you all know that? Yes, ma'am. Anything new? No, ma'am. So I've drawn all the x-axis and y-axis very roughly, because we don't have to draw in the exam. All you need to know is the nature. What is the behavior of all these functions? How these functions look like. That's what you all should know. Okay. So let's focus on that, not on my diagram. You all can see the origin also. Perfect. What is the first graph? The first one is sine, second one is cos. Shall I write it? Okay, let's write. This is sin x, cos x, tan x. Below sine, I'll draw cosec. Below cos, I'll draw sec. And below tan, reciprocal, which is cos. We will be also writing domain and range. Domain and range of all of them. Domain means whatever values you see on x-axis, and range means whatever value you see on y-axis. For drawing purpose, let's use green color. Okay, so sine function, you all know sine 0 is 0. Sine 0 is 0. Sine 90 is 1. Sine pi is again 0. Iska pi, uska pi, sabka pi. Sine 0, sine pi, sine 2 pi, sine 3 pi, sine 4 pi, sine 5 pi. Everything is 0, isn't it? Yeah. Sine pi 0. So, yeah. So, this is how the graph is. 0, then 90, then again 0, then minus 1. This is minus 1. Yeah. So, sine curve, this is how your sine graph is. It's a sinusoidal curve, like a wave. Remember, the wave starts from origin. That's all you need to know. What is sine graph? It's a sinusoidal, it's a wavy graph, starts from the origin. The highest value is plus 1 and the lowest value is minus 1. All other values are between 1 and minus 1. It's a nice continuous curve. Highest plus 1, lowest minus 1. So domain and range. Domain means x-axis. On x-axis, everything is taken, all real numbers. On y-axis, only between 1 and minus 1. So minus 1 to 1 is the range. Minus 1 to 1 is the range. Closed interval, because yeah, minus 1 and plus 1 are also included. When you come to cos, cos of 0 is 1. So it starts from 1. Cos 90 is 0. This is how your cos graph is. Sorry. This is your 1 and the lowest value is minus 1. Again, can you see? Highest value 1, lowest value minus 1. Cos is a sinusoidal curve, line between 1 and minus 1. Okay, anyways, on x-axis every value is taken, so domain is all real numbers, but on y-axis only one, everything between 1 and minus 1 is included. So range is minus 1 to 1, closed interval. We are going to write this on the next table also, don't worry. For now, from the graph, try to understand. X-axis, everything. Y-axis, 1 and minus 1. So y is range, domain is x. Tan x graph. Tan x graph is plus infinity to minus infinity. Absolute plus infinity, चांद तारे तोड़ लाऊं और जमीन पाताल में डाल दूं मैं, ऊपर से लेके नीचे तक, from absolute top to absolute bottom, plus infinity to minus infinity. You all know that step. That rope step, mirror step, huh? Something of like that. So tan graph, this is how your tan graph looks like. Why it looks like this? Tan 0 is defined, tan 0, 0. But tan 90 is not defined. So at 90 you can see it's going either to plus infinity or absolutely down minus infinity. Do not take the graph exactly, because I'm not measuring and drawing it. So little bit here and there, but I'm explaining the concept to the point. Tan in 90, tan is not defined. We all know tan 90 not defined. So 90 plus infinity minus infinity. Similarly, tan pi is defined, but tan pi is again 0, but tan 3 pi by 2. All the odd multiples of tan is not defined. So 3 pi by 2 plus infinity minus. So the graph of tan is Chanditare Todil. Okay, from right to left, right to left. Everyone will dance with me. Right to left, right to left, right to left, right to left, up, down, right to left. What is domain? Domain, is it all real numbers now? No, I am not taking 93, 270. I am not taking odd multiples of 90 because tan odd multiples of 90 is not defined. So domain is all real numbers minus odd multiples of 90. 2n plus 1 pi by 2 is nothing but odd multiple of 90. 2n plus 1 gives me odd numbers. So from real number, remove the odd numbers, odd multiples of 90. That's your domain. This, This the graph continues, yeah. On the left side also, the no space, leave it. What about the range, yeah? What about the range? You can see everything from plus infinity to minus infinity. So minus infinity to plus infinity, everything. Open interval because infinity never included. The other way of writing can be all real numbers. Range, that means y-axis is everything, everything above, everything below, no gap. Next graph. Let's do cortex immediately. Yeah, this is correct now. Right. If tan is right to left, cot is left to right, but with a shift. Right? With a shift, left to right. Up, down, left, right. Everyone will do left, right, but with a shift. This is origin. We all know quad 0 is not defined. This is how the chord graph goes. Okay. Why? At 0, can you see at 0 it's going either to minus infinity or plus infinity here. Plus infinity. Cot pi by 2, it's defined 0. Cot 3 pi by 2, 0. Cot 5 pi by 2, 0. But all the even multiples 0, pi, 2 pi, minus pi, minus 2 pi. We all know quad 0 not defined. Do we know quad 0 not defined? Yes. So domain of quad is all real numbers except even multiples of 90. Except the even multiples of 90. Even multiples of 90 can be written as 2n into pi by 2, 2 to cancel n pi. Odd multiple 2n plus 1 pi by 2, even multiple 2n pi by 2. 2n is even, 2n plus 1 is odd. 2 to cancel n. So domain is all real numbers, but you remove the even multiples because at 0, pi, 2 pi, quad is not defined. Range, plus infinity to minus infinity, you can write it all real numbers or minus infinity, whatever. All real numbers. Range is same like that. Coming to second cosec, my dear boys and girls, if you want to draw the graph of second cosec, all you need to know is the graph of sine and cos. Draw the graph of sine. Drawn. Now above sine and below cos, you will find the touching. This green part, ignore the red part, guys. Red part is sine graph. Ignore the red part. This green part, just the green part is cosec graph. Above sine, below sine. And similarly, draw the graph of cos. Cos starts from 1. So 1. You all should draw this, practice this. Above cos, below cos. Sorry. Touchy, touchy, huh? No crossing, crossing. Touchy, touchy. This is how the no crossing, touching. This is your seg graph. The green part is your seg graph. Remove the red part, guys. Let me see if I can remove the red part. Sorry, no, I can't. Can I? No, let it be. So ignore the red part. You can refer your textbook. So sec is above sine, below sine. Sec is above cos, below cos. What about the domain and range? The domain, all real numbers? No, it's not all real numbers. You can see it's going to infinity, minus infinity. Cosec of what is not defined? Cosec 0 is not defined. Sin 0, 0. Cosec 0, 1 by 0 not defined. Cosec 0 not defined. 0 is even multiple. 0 is even multiple. 0 is even multiple. So domain is all real numbers minus n pi. Remove the even multiples. What about range? Range is above 1 and below minus 1. थोड़ी सी तो left करा दे. थोड़ी सी तो above 1, below minus 1. Not in between 1 and minus 1. Cosec is never between 1 and minus 1. Sec is never between 1 and minus 1. Above 1, below minus 1. So above 1 and below minus 1 can be written like this. If you can understand, minus infinity to minus 1 union 1 to infinity. Or it can also be written as all real numbers minus 1 to 1. From all real numbers, you remove this red part. From all real numbers, removing minus 1 to 1. This is 1. This is minus 1. So between 1 to minus 1, from all real numbers, remove 1 to minus 1. You will get the range of cosec. And similarly, that's the range of sec also. From all real numbers, you will remove this minus 1 to 1. All real numbers, you will remove minus 1. Because it's always other than minus 1 and 1. Domain, what about domain? Sec of what is not defined? Sec 90 is not defined. 90 is odd multiple. Domain will be all real numbers minus 2n plus 1 pi by 2. From all real numbers, you will remove the odd multiples. So this precious page, I am now going to change. And fill it here. Domain for sin x. Let's keep it stylish. Domain was all real numbers, all real numbers. Range was minus 1 to 1, minus 1 to 1. For tan and cot, domain was tan all real numbers except odd multiples of 90, because tan 90 is not defined. Cot of 0 is not defined, so remove even multiples of 9. For tan, the range was plus infinity to minus infinity. For cot, the range was plus infinity to minus infinity. Right to left, left to right. Second, cosec. What's the domain? Sec of 90 is not defined. So from sec, remove the odd multiples of 90. 90 is 1 into pi by 2, odd multiple. Cosec of 0 is not defined. 0 is even multiple of 90, remove n pi. Second cosec, both are always above 1, below minus 1. So from all real numbers, you remove minus 1 and 1. I hope this table will be by hearted by all of you. No need to by heart. I told you enough reasons, enough logic to remember, to understand. But still, if you can't, you have to by heart then. Okay, which of the following is not correct? Sin theta minus 1 by 5. Can sin theta be minus 1 by 5? Yes, it's true. Sin theta will always be between minus 1 and plus 1. So minus 1 by 5, correct. We want not correct. Okay. Cos theta 1, is it possible? Yes. Cos theta also lies between minus 1 and plus 1. So this is also correct. Sec theta half. Sec theta is never between minus 1 and 1. What is sec theta? It will always be other than minus 1 and 1. Above 1, below minus 1. Can sec theta be between minus 1 and 1? No, this is incorrect. We needed the incorrect answer. So option C is correct. Check for D also. Can tan be 20? Tan can be all real numbers. What is the range of tan? All real numbers. Value of tan, plus infinity to minus infinity. Can tan be 20? Yes. Very well. Tan can be 20. Tan can be 100. Tan can be 1 lakh, 10 lakh. Because tan can be plus infinity to minus infinity. But sec will be always above 1, below minus 1. Half is somewhere between 1 and minus 1. I cannot see sec in between 1 and minus 1. That's the wrong answer. Removed. Next one. Which one is greater? Which one is smaller? 1 radian. Okay. 1 radian we also studied. 57 degrees, 16 minutes, 22 seconds. But they have given very high amount of approximation. This is a very highly approximated value. But it's fine. We can take. So yeah. Sine 1 degree is greater than sine 1. Nothing means radians, guys. This nothing means radians by default, okay? Okay. So they are saying sine of 1 degree is greater than sine of 1 radian is 57 degree. I am approximating it even further. 1 degree is greater than 57 degree. Which one is correct? You have to tell me. Sine 1 degree is equal to sine 57 degree. Sine 1 degree is less than sine 57 degree, or sine of 1 degree is equal to pi by 180 times sine of 1 radian, which is 57. Just observe the behavior of sine. What happens in sine? If you look at the graph of sine, in sine, as theta increases, in sine theta, as theta increases, sine theta also increase. Do you agree with me? Let's take the example. Theta 0, sine theta 0. Theta 30, sine 30, 0.5, half. Theta 60 degree, sine 60 is root 3 by 2. Root 3 is 1.73 upon 2. That's roughly 0.8, 0.9. Theta 90 degree, sine 91. So can you say as my theta is increasing, sine is also increasing? So somewhere in between there will be 1 degree which we are interested, and somewhere here there will be 57 degree. So between 1 and 57, which will be greater? Of course sine 0 is smaller than sine 30, which is smaller than sine 60, then smaller than 9. Theta increase, sine also increase. So for 1 degree will be smaller than 1 radian. Do you agree? This is correct. Sine 57 degree will be more than sine 1 degree. Sine 90 degree is greater than sine 0 degree. Sine 60 degree is greater than sine 30 degree. Theta more, sine theta more. Sine 57 will be more than sine 1. The right answer is option C. Sine 1 degree is less than sine 1 radian. Great, great, great. Very good. I hope you are having the time of your life studying this trigonometry. I think we did this trigonometric functions at minus x. Sin theta plus cosec theta is given. What is sin square theta plus cosec square theta? Linear angle, linear is given. We need quadratic square. Sin theta plus cosec theta, the whole square is equal to 2 square. A square plus b square plus 2 times a into b is equal to 4. We need sin square plus cosec square. What is sin into cosec? 1. Sin square theta plus cosec square theta plus 2 is equal to 4. 2 goes on the other side. The answer will be C. Right? Next. Tan theta is 3. Theta lies in third quadrant. Then what is the value of sin theta? Guys, triangle method. You can use the identity if you have been taught like that in the school. But Pythagoras, Gora theorem we will use. Tan is opposite upon adjacent. 3, 1. Can you see tan theta is given as 3 by 1? Opposite adjacent. If this is 3 and 1, what will be the hypotenuse? 3 square plus 1 square, 9 plus 1, root 10. Hypotenuse is root. Now in this, we need sine theta. Sine theta according to the formula, simple, opposite upon hypotenuse. 3 by root 10. Theta is in third quadrant. In third quadrant, sine is negative, tan is positive. So minus. Sine theta will be minus 3 by root 10, option C. Sine in third quadrant is negative. This is what I was talking at the beginning. If one angle is given, you can find out all other 5 trigonometric functions. If they ask you cos theta, you can easily find adjacent upon hypotenuse, 1 by root 10, but minus sign, third quadrant. Sec, cosec, everything else can be found. Let's go to some formulas, trigonometric functions of sum or difference of angle. 4 formulas are already typed because I knew by this time I'll be a little tired, you will be a little tired. But 4 formulas I'll be writing down. It misses the formula for tan and cot. Well, remember, very important, sum and difference. Sine of x plus y, sine of x minus y, cos of x plus y, cos of x minus y. To remember this, I always tell my students, sine is like you guys, sine is like me, cos is like you guys. Sine is an extrovert and cos is an introvert. S for sine, S for same. Sine is an extrovert, cos is an introvert. So sine likes mingling up. Can you see? Sine with cos, cos with sine, sine with cos, cos with sine. Whenever there is sine, it's me, extrovert, mingle up. But when there is cos, cos is an introvert, doesn't like to mingle. Cos will remain with cos, sine, sine. Cos, cos together, sine, sine together. S for sine, S for same. Plus remains plus, minus remains minus. C for cos, C for change. Plus becomes minus, minus becomes plus. S for sine, S for same. C for cos, C for change. So whenever there is cos, you will change the sign. Whenever there is sine, you will keep it same. Plus, plus, minus, plus. Sine means extrovert, mixes up with everyone. Cos means introvert, grouping. Cos, cos together, sine, sine together. You will be able to remember this formula. Is this trick nice? With this trick, we will solve all the questions very easily. Adding more formulas. Now tan is in the family of sine. Tan, my dear students, it is in the family of sine, and cot is in the family of cos. Cot is in the family of cos. Okay, that means tan also retains the sign, whereas cot will change the sign. Tan of x plus y, the formula is a little different. Tan x plus tan y upon 1 minus tan x into tan y. Can you see plus remains plus and denominator opposite side. If it's tan of x minus y, I'll keep minus in the numerator. Tan x minus tan y, and denominator will have a opposite side. Tan x into cot. Cot is kind of reciprocal of tan. So the denominator will appear somewhere in the numerator. The formula is cot x into cot y plus will become minus upon cot y plus cot x. Numerator negative, denominator should be opposite, positive. Cot of x minus y. Minus means I am going to put plus because C for cot, C for change. Minus becomes plus. If numerator is plus, denominator should be minus, opposite. Always numerator, denominator, opposite. Cot of x plus y, cot x, cot y plus 1 upon Very important, cot y minus cot x. Everyone note, I have written cot y minus cot x. It's not cot x minus cot y. Most of the students make a mistake here. It's cot y minus cot x. Second minus first. If you write the other way, it will go wrong. Okay. So these are the 8 formulas which we need to by heart. I have also told you the tricks to remember. Based on it, a simple question. Tan theta, tan phi is known. Tell the value of theta plus. Use the formula of tan expansion, sum and difference. Tan theta. Tan also belongs to sine family. So plus remains plus, and in the denominator, opposite side. How much is tan theta? Half plus 1 by 3 upon 1 minus 1 by 2 into 1 by 3. Simplify. 5 by 6 upon 3 to the 6 minus 1, 5 by 6. What are we getting, people? Tan of theta plus phi to be equal to 1. That means when is tan value equal to 1? At pi by 4, theta plus phi is equal to pi by 4. Option number A. Understood? Simple application of the formula. This is a special type of tan question, exclusive questions on tan, and you may encounter many such questions. Understand? Tan 3a minus tan 2a minus tan a is equal to 1. Focus on the method of solving. Whenever you see 3a, 2a, a, that is 2a plus a gives 3a. You can have any other 3 number, let's say 7a, 5a, 2a. 5 plus 2 is equal to 7. Whenever you have any such combination, always start the question like this. 3a is equal to 2a plus a. Okay, this is based. Therefore, tan of 3a is equal to tan of 2a plus a, taking tan on both sides. Now, on the right hand side, you can use the formula which we just saw. Tan 2a plus remains plus tan a upon 1 minus tan 2a into tan a. Cross multiply. Tan 3a into 1 and tan 3a into this whole thing minus tan 3a into tan 2a into tan a is equal to tan 2a plus tan a. What is needed in the question? We need 3a minus 2a minus a. That means these two terms should be brought on the left and negative term taken on the right. Tan 3a, first term as it is. The right hand side 2 terms I am bringing here. Minus tan 2a minus tan a, and this whole negative term is taken on the right hand side, which makes it tan 3a into tan 2a into tan a, and the answer is option A. Please remember also this directly. Remember by heart. Many questions will be directly answered. 3a, 2a, a can be replaced with any other angle. A can be taken as any angle. Let's say it's tan of 60 minus tan 40 minus tan 20. You can directly, of course it's all degrees, you can directly say it's tan of 60 into tan 40 into tan 20 if there is any other option like that. So remember it as a formula also if you can. Moving on to the next, which is multiple or submultiple angle formulae, wherein double half angle formulae. Sin 2x has 2 formulas, 2 sin x cos x, extremely important, used a lot of time. Remember this 2x is becoming half, 2x is becoming x. And the other formula is 2 tan x upon 1 plus tan square x plus sine is positive extrovert just like me. Cos 2x has 4 formulas. Cos square x minus sine square x, 2 cos square x minus 1, 1 minus 2 sine square x, and the other one is 1 minus tan square upon 1 plus tan square. Depending on the question, depending on the requirement of question, you will use any one out of the 4. If you want everything in cos, you will use 2 cos square x minus 1. If you want in terms of tan, you will go for the fourth one. Remember, this 2x is becoming half. On the right side, you can see x. Tan 2x has only one formula, and by dividing these two, this, you will get tan 2x, sine by cos tan. 2 tan x upon 1 minus tan square x. Here there is plus, here there is minus, remember. Triple angle formulas. In triple angle formulas, speciality everywhere there is minus. Do not get confused, numerator minus or denominator will be plus. No, it doesn't work like that. In triple angle, everything is minus. Numerator, denominator, everything. Sin 3x is 3 sin x minus 4 sin cube x. When it comes to cos 3x, a small interchange. 4 cos cube x minus 3 cos x. Sin will have only sin terms, cos will have only cos terms, and tan will have only tan terms. Speciality. Other thing to note, tan 3x is 3 tan x minus, there is no 4. We have a habit, 3 sin x minus 4 sin cube x. There is no 4. 3 tan x minus tan cube x upon 1 minus 3 tan square x. That's it. So this double and triple angle formulas should be supplemented with 2 very important formulas used extensively. 1 plus cos 2x and 1 minus cos 2x. 1 plus cos 2x is 2 cos square x. You can say it's from cos 2x equal to this thing. Equate, this is what you need. And 1 minus cos 2x is 2 sin square. It is used multiple times. That's why I'm writing it separately. Whenever you see 1 plus cos 2x, you can write 2 cos square x, half of it. 1 minus cos 2x, 2 sin square x, half of 2x. Alright. Great. These are some half angles which, if we remember, a lot of questions are simplified. Sin 18, 36, 54, 72. 18 2s are 36, 18 3s are 54, and 72 is simply sine of 72 degree can be written as sine of 90 minus 18. Sorry, 90 minus 18, which is equal to sine of 72 can be equal to cos of 18. Sine 72 root 10 plus 2 root 5 by 4. Can you see it is same as cos of 18? Similarly, sine 54 can be written as 90 minus 36, and sine 54 is same as cos 36. Sine 36 can be written as 90 minus 54. Sine 36 is same as cos 54. Sine 18 can be written as 90 minus 72, and sine 18 is same as cos 72. So if you remember any one side, the other side can be easily found out. Sine 18 same as cos 72, sine 36, what is, 72 is same as 18, 54 is same as 36, and 36 is same as 54. That mess, you make it for yourself, right? You make this arrow diagram for yourself. I've told you the logic and how to find sine 18 degree, and it's an altogether different question. But remember, root 5 minus 1 by 4, at least sine 18 and sine 54 you remember, it's easy. Root 5 minus 1 by 4, root 5 plus 1 by 4. Let's find the value of 1 minus tan square 15 upon 1 plus tan square 15. Looks a little similar formula, isn't it? Looks a formula similar to this. Cos 30, cos 2 theta, or cos 2 theta is 1 minus tan square theta upon 1 plus tan square theta, isn't it? If this is theta, cos will double it. So if this is 15, isn't this equal to cos of double 2 times 15, 30 degree? And cos of 30, my dear kiddos, is root 3 by 2. Simply answer is C, based on a formula that we know. Value of cos 1 into cos 2 into cos 3 into cos 4 into cos 5 into cos 6 into dot 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 till cos 179. Now you must be thinking it's something like your tan question, tan 1, 2, 3, 4 till 89. No need to think so much. It's very simple. Can you understand? In between there is a hidden number. In between there is somewhere cos 89, and then there is cos 90. And what is the value of cos? What is the value of cos 90? 0. So if cos 90 is 0, 0 into any number is going to give me 0 only. The answer is 0. If you would have paused and thought about it, maybe you wouldn't have found this small thing. Many times such a simple question appears, yes, in JE also. Just, trouble. Moving to the last part, which is transformation formulae, 4 plus 4, 8 formulas. Sum to product, 4 formulas, product to sum, 4 formulas. Now moving from sum to product. Always remember, sine and sine. With the help of these 2 formulas, I have remembered the compound angle formula, sum and difference formula. Sine is an extrovert. Sin x cos y, cos x sin y. So simply remembering, plus means first term and minus means second term. Okay. And similarly, cos of x plus y was cos x cos y minus sin x sin. I'll remove this minus. Yeah. Whenever you have plus sign, you will go with the first term. Whenever you have minus sign, you will go with the second term. Is that simple? Are the rules of game understood? Game rules very simple. Plus sign, take the first term. Minus sign, take the second term from these 2 forms. Sine in the expansion of sine. Plus means first term is sine and cos. Sine is an extrovert, so sine and cos is the first term. Sine in the expansion of sine. Minus means second term. Sine is an extrovert. In extrovert, second term is cos into sine. First term sine cos, second term cos. In cos, cos, expansion of cos. Plus sine, cos is an introvert. What is the first term in expansion of cos? It is 2 cos. And cos in the expansion of cos, minus sine means second term in the expansion of cos is 2 sines together. So sine and sine. But remember, whenever 2 sine gets multiplied, sine is an extrovert. So when 2 extroverts will come together, will there be a fight? Will there be a little negativity produced? Yes. So whenever 2 signs multiply, guys, a negative sign is produced. Please remember, this is the only exception. Nowhere else you can see the negative sign, only here. So 2 sin c plus d by 2 into cos c minus d by 2. If it's minus sign, I'll pick up the second term of an extrovert, cos c plus d by 2 into sin c minus d by 2. 2 is always there everywhere. Cos c plus cos d, 2 cos c plus d by 2 into cos c minus d by 2, and sin cos c minus cos d will be equal to minus sin into 2 sin c plus d by 2 sin c minus d by 2. The other way, if you don't like this minus, if you are like you don't want to write this minus, the other way can be 2 sin c plus d by 2 into sin, instead of c minus d you can just interchange it as d minus c. Take this minus sign here inside, it will become d minus c. So sum to product rules are simple: plus sign first term, second time, minus sign second term. And sign means you will extrovert, mixing up. Cos means no mixing, cos, sin, sin. Next 4 formulas that I am going to present, the rules remain same. It's product to sum. Left side is multiplication, right side is addition or subtraction. Now in multiplication, you have an extrovert. Where do you see extrovert? In sine or cos? You see in sine, so write sine. Cos and sine, where do you see cos and sine? Extrovert, you write sine. Sine and cos. Sine cos is the first term, plus sign. Cos sine is the second term, minus sign. What first sign? Oh my god. Okay, let me write it again. Let me just rewrite. Did I move it? Yeah. Cool, fair enough. In the expansion of sine, it was sin x cos y and cos x sin y. So because there is sine into cos, it's the first term, I put a plus sign here. And here it's cos into sine, it's the second term, put a minus sign. We know the rules are simple. Plus first term, minus when it's a second term. And similarly in cos also, it's cos x cos y and sin x sin y. So if you see cos together, it's in the expansion of cos, it's an introvert and first term, that's why plus sign. When you see sin and sin together, it's the second term. Second term, that's why minus sign, and sin, introvert. Introvert means cos. Introvert, cos. Introvert, cos. Extrovert, sin. Extrovert, sin. First term plus, second term minus, first term plus, second term minus. But do you remember when two sign multiply, there is negativity produced? When two extroverts come together, negativity produced. When two sign multiplies, there is some problem. So what is that problem? A plus b, a minus b, a plus b, a minus b, a plus b, a minus b. Oh, a minus b and then a plus b. Remember the fourth one. When two signs multiply, it's a special case, right? Two extroverts. So a minus b will come first and a plus b will come later. That's what you have to remember. The fourth one. I hope you enjoyed this trick. How did you find the trick, guys? I have remembered all the formulas using this introvert extrovert technique. Instead of teaching for, even after teaching for so many years, I wouldn't have remembered if I myself wouldn't have sat for so many hours to understand the trick, to make it myself, convince myself, and then go about it in my classes. All my students have benefited a lot from it. I hope you also will like it. Do let me know. Value of sine: 20 degree, 40 degree, 60 degree, 80 degree. There are different approaches. You can see too many things in multiplication. Now you have seen so many formulas in trigonometric function. Which formula to use? We always try to figure out, or rather I suggest my students, do everything that clicks, that you feel you should do, try it, because unless you try, you won't understand out of 10 why one method is being used. Also, a particular question can be solved by more than one ways. There is no one standard way to solve a question. Through different methods, we can get the same answer. So do try your own methods, go by your instincts, and only practice is going to make you perfect in all these questions. Slowly you will develop logic. Why? How come ma'am knows which formula to use? Like for example, here too many things in multiplication. Multiplication we know formula product to sum. That can be used. But I am going to solve this question through a shortcut method. And what is that? Sin 60 is root 3 by 2. We are left with sine of 20 degree, sine of 40 degree and sine of 80 degree. Everybody, other ways you multiply, divide with 2 and use the formula 2 sine A sine B. It is cos of A minus B minus cos of A plus B. It's an introvert, that's why cos. It's a second term, that's why minus sign in between. that can be done. You do it by that method. Well, I am going to use a different approach, which is, can I write 40 as 60 minus 20 and 80 as 60 plus 20? Okay. Why am I doing that? Because there is a formula, sine of a plus b into sine of a minus b is equal to sine square a minus sine square b. And why this formula comes? Where this formula? Ma'am, you didn't tell about this formula. There are many such shortcuts. I would want you to try. You now know so many formulas. You can definitely try to prove this one. But for now, remember it to solve this question. Root 3 by 2 sine of 20 degree. Using the formula, I can get sine square 60 degree minus sine square 20 degree. This is root 3 by 2 times. Taking sine 20 inside, sine square 60 will be root 3 by 2 square 3 by 4. 3 by 4 times sine 20 minus sine cube 20. Alright, and where is this cube appearing? In all the formulas that you have seen so far, cube appears only in triple angle. So something related to triple angle, if you can see. Cross multiply the terms inside bracket. 3 sine 20 minus 4 sine cube 20. Hooray! Who all can see? Who all can see? 3 sine theta minus 4 sine cube theta. This 2 multiplies root 3 by 4. How many of you all can see the triple angle formula? It is nothing but sine of 3 times theta. Theta is 20. This is root 3 by 4 times sine 60. Sine 60 is root 3 by 2. And that's equal to, oh my god, there is no option like that. Well. Oh, this is 4. Simple. This is 4. Make it 4. This will become 8. Denominator after cross multiplication is 4. 4 2s are 8 is left here. Right? So, on simplification, root 3 by 8 into root 3 by 2, 3 by 16. Plus minus plus. Option is C correct. Understood? As I said, do try the other method also, which is product to sum. Multiplying, dividing by 2. Just try to introduce 2 here and apply the formula of 2 sin x sin y. Next question. Cos pi by 5 into cos 2 pi by 5 into cos 4 pi by 5 into cos 8 by 5. Various methods. Again, I myself can solve by 3 methods. But because the lecture has already extended, 1 hour session has become 2 hour, I'll try to curtail and use the simplest method available to me. Multiplying and dividing. Multiplying and dividing by 2 sin pi by 5. And why is that? Why? Why am I doing it? 1 upon 2 sin pi by 5 divided and multiplied also. 2 sin pi by 5. There's already cos pi by 5. And then rest of the terms as it is just copied up. See, now you're going to enjoy. Can you see a formula? How many of you all can see a beautiful formula? Yo. 2 sin theta cos theta is sin 2 theta, double angle formula. Pi by 5 will become 2 pi by 5, sine of 2 pi by 5 into cos 2 pi by 5 into cos 4 pi by 5, and this chain reaction is now going to keep on happening till we get the last term. 2 is missing. To make it a formula again, 2 is missing. Let's divide and multiply by 2. Everyone, dividing by 2 and multiplying by 2. The term outside will become 1 upon 4 sine pi by 5. Inside the bracket you can again see a formula. 2 sine theta cos theta is sine 2 theta, double of 2 pi by 5. That's equal to sine 4 pi by 5 into cos 4 pi by 5 into cos 8 pi by 5. Well done. Again something is missing, which is 2. So once again multiply and divide by 2. Outside it's 4 2s are 8 sine pi by 5. Inside the bracket you all can see 2 sine theta cos theta is sine 2 theta, double angle. Sine 8 pi by 5 into cos 8 pi by 5. Something missing. Let's multiply divide by 2 and that will make it a formula. Finish it. 1 upon 2 8s are 16 sine pi by 5 into this is sine 16 pi by 5. My dear bachcho, let's simplify. 1 by 16, let it be. Sine of 16 pi by 5, can I write it as 3 pi plus pi by 5? Check out. 3 pi plus pi by 5. Cross multiply, you will get 16 pi by 5. Check. 5 3s are 15 plus 1, 16 pi by 5. And now by allied angle, what is sine of 3 pi plus theta? What is sine of 3 pi plus theta, everybody? 3 pi is an odd multiple or even? Even. So sine remains a sine. Is it first quadrant, second, third, fourth, what? 3 pi. 3 pi. So 0 pi, 2 pi, 3 pi. 3 pi plus theta is third quadrant. And in third quadrant, sine is negative. So it will be minus sine theta. That means numerator is minus sine pi by 5. Denominator is sine pi by 5. Cancels. The final answer is minus 1 by 16, which is option D. Option D is the correct answer. Got it? Are you getting it? Awesome. Enjoyed it? Very good. Practice questions? No, don't worry. I don't have much practice questions. Just one type of question, maximum and minimum value. So giving you a shortcut again. If you have a question of the format a sin x plus b cos x, always its minimum value will be minus root of a square plus b square and maximum value will be plus root of a square plus b square. Note down this formula, please, everybody. Very important. A sin x plus b cos x format, minimum value and maximum value. Direct questions come on this. I think nothing else is left from this chapter. I have tried covering everything. Here's a question. What is the greatest value of sin x into cos x? Greatest means highest. Sin x into cos x. Well, if I multiply and divide by 2, I'll get something again. This is equal to 1 upon 2. 2 sin x cos x is sin 2x. We know one thing for sure. Sine always lie between minus 1 and plus 1. Sine of any angle will lie between minus 1 and plus 1. Everyone knows the range of sine is between 1 and minus 1. Correct. So sin 2x will be between minus 1 and plus 1. I want half of sin x. That means divide throughout by 2 throughout. The middle term will be sin 2x by 2 minus 1 by 2 and plus 1 by 2. Can you see this is your minimum value and that's the maximum value. Sin 2x by 2, its minimum value is minus half, maximum value is plus half. We wanted the greatest value, so the answer is plus half. The question sin x into cos x, how we modified into a known formula. Sin x into cos x is Sine 2x by 2, sine 2x by 2 lies between -1 plus. What is the minimum value of 3 sin x plus 4 cos x plus 8? Well, we can easily find out the minimum value of this term. Yes or no? We just saw the formula. Minimum value is equal to minus root of, comparing it with the formula, a square plus b square. Minimum value of 3 cos x plus 4 sin x is equal to minus root of 25, which is minus 5. But do we need the minimum value of this? No, we need minimum value of plus 8 is added to it. Therefore, minimum value of 3 cos x plus 4 sin x plus 8 is equal to minus 5 plus 8, that's equal to 3. Option B. It can be written like that. It can be written in this form, that which is always better. I mean, I like to write it like this. 3 cos x plus 4 sin x will lie between minus root of a square plus b square and plus root of a square plus b. That is 3 cos x plus 4 sin x will lie between minus 5 and plus 5. Because 8 is needed, add 8. Add 8 throughout. 13 and 3. So that's your minimum value and maximum value. In case they would have asked the maximum value, 13 would have been the answer. Super. What is the value of tan 75 minus cot 75? Let's first find tan 75, which is tan of 45 plus 30, which is according to the formula tan A plus tan B upon 1 minus tan A into tan B. 1 plus 1 by root 3 upon 1 minus 1 by root 3. From here, tan 75 is equal to cross multiply root 3 plus 1 upon root 3 minus 1. Cot 75 will be simply reciprocal of tan 75. Do you agree? Alright. You have got both the things, subtract. So guys, although there are unlimited number of questions in this chapter and we can literally do as many questions as needed, we will have to take a pause somewhere. Okay. Do we need to cross multiply? Yes. Root 3 plus 1 the whole square minus root 3 minus 1 the whole square. And I think it's a time that I take a pause for this particular chapter today in this session. Don't worry, more sessions will come. A square plus b square plus 2ab, a square minus a square plus b square minus 2ab will become plus 2 root 3 upon 3 minus 1. 3 3 1 1 2 2 4 root 3 3 minus 1 2 2 ones are 2, that's equal to 2 root 3. Be the answer option. Okay, so I think I have covered the chapter from all the perspectives and I have justified it very well so that I can sleep peacefully tonight. We will be meeting in more sessions to deal with more questions. Do let me know if you like and enjoyed the efforts. Keep dancing, smiling always. Balle balle. Let's meet very soon. Till then, take care, bye bye, and keep smiling. Thank you.